In the previous class, we have seen that the images formed by a plane mirror is erect, virtual, and is of same size as that of the object. Okay, but the nature and size of the images found by spherical mirrors always depends upon different factors. Okay, what are those factors on which the images found by spherical mirror depends is, first one, the nature of the mirror, and the second one, distance of the object from the mirror or from the pole of the mirror, and third one, focal length of the mirror. Okay, so images found by spherical mirror always depends upon three factors: nature of the mirror, distance of the object from the pole of the mirror, and focal length of the mirror. Okay, the exact nature and size of the images found by these objects kept at different positions in front of a spherical mirror can be explained or drawn by simple diagrams, and that diagrams are called ray diagrams. Okay, in order to draw the ray diagrams, certain instructions we need to follow, and certain rules are there in case of construction of images by using ray diagrams. Okay, now we will first discuss about rules to draw ray diagrams. So we know that infinite number of rays travel from the object towards the mirror, but we need to know any of at least two incident rays whose paths after reflection from the mirror are known. Suppose if this is the object, it will give a large number of rays from each and every point, and which will travel towards the mirror and gets reflected. Out of these many number of rays, we need to know two incident rays for which we know the reflected rays in order to get the image. Okay, and now we have convenient incident rays. Out of these convenient incident rays, we have to take any two of the rules, and we can draw the image diagram. Okay, ray diagram for the formation of images. Two of the rules we need to consider, and we can draw the image diagram by using the following rules. Okay, now we'll see that rules. Now this is rule 1, in which I am considering a concave mirror. Okay, we have already seen that a concave mirror has outer side or bulged surface side coating, and inner side is reflecting surface. Okay, now this is the principal axis. Now this is the principal axis. Now this is one incident ray. Okay, this is one incident ray which is incidenting at this point on the concave mirror. Okay, now if we draw a normal which passes through the center of curvature, at this point we need to draw the normal, and normal always passes through the center of curvature. Then after reflection it gets reflected, and for one side of the normal we know it is the incident ray, and on the other side of the normal there will be reflected ray with the angle which is equal to angle of incidence. Okay, now suppose if we take the same angle of incidence, now this ray passes like this. It is observed that this is the focus. Now it is passing through the focus. Now we can define this as any parallel ray which is parallel to principal axis fall on the concave mirror or incident on the concave mirror. It gets reflected and passes through the focus. Okay, this is the first rule in case of concave mirror. Now if we take convex mirror, now this is the convex mirror for which inner side is coated and outer side is reflecting. Outer side is reflecting. Now this is the principal axis. Now if we consider a incident ray, now this is the incident ray which is parallel to principal axis. Okay, it is falling on the mirror at this particular point. Now again we need to draw the normal at this point, and the normal always passes through the center. This is center and here it is focus. Okay, now after reflection this is the angle of incidence, angle I, and with this same angle the ray gets reflected, and as it is a diverging mirror, now it gets reflected like this. Okay, now if we extend this one inside the mirror, it will touches the point focus or focal point. So when a parallel ray parallel to principal axis incident on the mirror, it gets reflected and it appears to be coming from the point F or focal point. Okay, this is the first rule. Now we'll discuss rule 2. For that again I am considering concave mirror. This is a concave mirror. Now this is the principal axis where it has focus. Now this is center of curvature. Okay, in the previous rule we have seen that a ray coming parallel to the principal axis will incident and after reflection passes through focus in case of concave mirror and convex mirror. Now here converse to that, if a ray coming or passing through the focus and incident on the mirror. Okay, now if we draw a normal which passes through the center of curvature, now on one side we have incident ray, on the other side we will have a reflected ray. Now this is a reflected ray which is observed that it is parallel to the principal axis. Now how can we conclude? If a ray that passes through the focal point of the mirror will travel parallel to the principal axis after reflection. Okay, now we need to write like this in the exam. Now if we take convex mirror, now this is the convex mirror where it is coated inside. Okay, now again this is the principal axis. Okay, this is focus, this is center of curvature. Now if we imagine a ray, if we consider this ray, okay, incidenting at this point. Now if we draw a normal at this point which passes through center of curvature. So normal drawn at the point of incidence always passes through center of curvature. Now this is the angle of incidence, and after reflection the rays get reflected with the same angle. Now this is the reflected ray which reflects with the same angle of incidence, and this is called angle R, angle of reflection. Okay, now it is concluded that if a ray appears to be coming from the focus, now if we extend this, we'll get it is passing through the focus. Now the rays coming along the direction in the of focal point gets reflected and passes like a parallel ray to the principal axis. Okay, now we will go for rule number 3. For that I am considering a concave mirror. Now this is a concave mirror. Now this is a principal axis where it will have focus and center of curvature. Now I am considering a ray, incident ray, which incident at the pole of the mirror, and this is the angle of incidence, angle I. Okay, and principal axis itself acts as a normal, so that for this normal there is incident ray on the one side and there will be a reflected ray on the other side, means downside. Now if we draw an reflected ray with the same angle of reflection as like angle of incidence, we will get this one as a reflected ray. So we will define this rule as, if a ray incident on the mirror at pole with a certain angle of incidence, angle I, then it gets reflected with the same angle of reflection which is equal to angle of incidence on the opposite side of the normal or on the opposite side of the principal axis. This is the rule number 3, and we can draw this same rule in a convex mirror. Now this is a convex mirror where it is coated inside, and this is the principal axis. Okay, now we will consider an incident ray, incident at the pole. Okay, now this is the angle of incidence. Okay, principal axis itself acts as a normal, then this ray gets reflected from the pole with the angle of reflection which is equal to angle I, which is called angle R. Okay, so we can define rule 3 as a ray, incident ray, when it falls or incident on the mirror at a pole with a certain angle of incidence, angle I, then it gets reflected with the same angle of reflection equal to angle of incidence in the opposite direction to the incident ray. Nothing but on the both the sides of the principal axis there will be incident ray and there will be a reflected ray. Okay, now let us see rule number 4. For that, again I am considering one concave mirror, and this is the principal axis where it will have focus and center of curvature. Now if a ray touches the mirror passing from center of curvature like this, if a ray comes like this and incident on the mirror at this point, then it will be get reflected in the same direction, because the normal will be on the same line which passes through the center. So when a ray passing through the center of curvature and falls on the mirror, it gets reflected in the same path, means it retraces its path. Okay, now the same diagram will draw for the convex mirror. Now this is convex mirror which is coated inside. Okay, now this is a ray which is incident on it. Now this is the principal axis where we have focus, and this is the center of curvature. Now if we take or extend this ray and which touches the center of curvature, okay, again it traces back in the same path. Okay, this is a rule in case of convex mirror. Okay, now once we will recall all the rules. Rule 1. In rule 1, this is a concave mirror and convex mirror. Concave mirror and this is convex mirror. Okay, we need to write the description for the diagram also. Okay, how we'll write means all the rays that are coming parallel to the principal axis, gets reflected such that they passes through the focal point of the concave mirror. Okay, now if it is a convex mirror, they are reflected by this convex mirror as if they are coming from the focus. Okay, now second rule. This is the concave mirror again. Now if the rays coming through the focus and incidenting on the concave mirror, then they gets reflected in a direction parallel to the principal axis. Okay, the same thing in case of convex mirror also. Okay, this is the ray coming and incident on the convex mirror and gets reflected, travel as a parallel ray to the principal axis. Now rule number 3. A ray, incident ray coming and incident on the mirror, concave mirror at pole, then it gets reflected in the direction which is on the opposite side to the principal axis with the angle of reflection equal to angle of incidence. Okay, ఏదైనా ఒక రే పోల్ దగ్గర ఇన్సిడెంట్ అయితే with certain angle of incidence angle I, then ఇంతే angle of incidence తోటి principal axis కి opposite direction లో angle R అంటే angle of reflection R తోటి రిఫ్లెక్ట్ అయ్యి వస్తుంది. నెక్స్ట్ కాన్వెక్స్ మిర్రర్ లో కూడా సేమ్. దిస్ ఈస్ ద ఇన్సిడెంట్ రే incidenting with angle I and gets reflected with angle R. Okay, now this is the rule 4. In case of concave mirror, if any ray passes through the center of curvature and incident on the mirror, then it gets retraces in the same path, because normally is also on the same line, and this is in case of convex mirror. Okay, so these are the 4 rules we have to draw the ray diagrams for the formation of images. In order to draw the ray diagrams for the image formation, we need to consider any 2 of these rules. Rule 1, Rule 2, Rule 3, Rule 4. Any of these 2 rules can be used to draw the image formation. In the next class, we'll discuss about the formation of images, or to draw the ray diagrams for the formation of images by using these rules. Okay, thank you.